All right. When we do lookalikes, the focus should be on composition. So we now know these rules for exponents, but how do we know when to apply them? We have to recognize composition first. That's why it's so important. So remember, the rules of exponents only apply to separate factors, not between terms. So we have to make sure we have the situation. So this first problem for a, we have a cubed times a cubed. Well, these are just factors. It is multiplying, so I just use the exponents to add. So it is multiplying common factors, right? So we can just take this, add the exponents. This would be a to the sixth. The next problem, again, we look at the composition. This is one term, and if you notice the parentheses, we have this outside power. We have a factor to a power, basically one factor to a power. So we're able to multiply those exponents and rewrite it as a to the ninth power. The next problem we look at, well, this composition, because of the plus outside, we have two terms. We have two terms. So none of the properties of exponents apply. We have to combine like terms. So when we look at terms, how are they alike? So we're recognizing like terms by looking at the variable factors. So both of these terms are alike, so we can just combine them by adding the exponents of 1 and 1. So this would be a 2a cubed. So we don't change the variables, we just combine 1a cubed and 1a cubed is 2a cubed. All right, so what about this next problem? So we did these before. I don't want us to get thinking that it looks the same as what we have. We do see the parentheses and we see this outside power, but the inside is not one factor or one term. The inside is actually two terms. So this is a binomial, two terms, a binomial to a power. In this case, it's squared. This is a binomial squared. We call this BS to make sure we kind of see this. But for this problem, we know that there's distributions that we need to do. And remember that when we square this, we get the first term squared. This is a squared. A times a is a squared. Then we do the last term, 3, and we know that's squared. 3 times 3, or plus 9. And the middle term comes from distributing the 3 times a and doubling it. So because of the different distributions, this has another term of 6a. But it's really easy to get caught up on thinking we just apply the power to those terms. We apply the power to individual factors. It's so important that we say what we're reading and use composition to keep us from applying the properties inappropriately or not appropriately. So just to practice again, the last three problems here, we notice here, the first one in A, we have one term. In the parentheses, we have a factor raised to a power. So this is just one factor raised to a power. So we do multiply exponents. This is our property. So this would be m to the 5 times 7 or 35th power. The next problem, because it's multiplication between, these just represent two factors. And since they're common factors of m, we can use properties of exponents to write that as just m to the 5 plus 7, just add up the exponents, 12. So we're just multiplying common factors there. But again, here, we notice before we do this that these are actually two separate terms. So again, we have two terms. The properties of exponents do not apply here. Can I combine these terms? Well, these terms are not alike. They have different variable factors, so they're not alike. So the expression is just left alone. There's nothing to do with this problem. So it's so important, again, to focus on composition before you apply any properties. Properties of exponents only apply to factors. They do not apply across terms.